In criminal investigations, toxicological examinations play a critical role in determining the presence of drugs, alcohol, poisons, or other harmful substances in individuals involved, whether they are victims or suspects. Understanding the results of these analyses can provide investigators with invaluable insights into how a crime may have unfolded, potentially determining causes of death, impairment levels, and even intent. Firstly, what does a toxicological examination involve? A forensic toxicologist examines bodily fluids like blood, urine, or tissues to identify and quantify substances such as drugs, alcohol, and toxins. This process can shed light on several important questions. Was the victim impaired at the time of the incident? Was the suspect under the influence, which could affect their behavior? Could the presence of a poison indicate intentional harm? One famous example of how toxicology can influence a criminal investigation is the case of pop star Michael Jackson. Toxicologists found lethal levels of propofol in Jackson's system, a substance administered by his personal physician. The findings of this examination were pivotal in proving that Jackson's death was caused by an overdose of a powerful anesthetic, leading to the conviction of his physician for involuntary manslaughter. Toxicological reports don't just confirm the presence of substances, they also help reconstruct the timeline of events. The metabolization rates of various substances, such as alcohol or narcotics, can offer a window into when they were consumed. This can be critical in determining, for example, whether a suspect was impaired at the time of committing a crime or whether the substances were taken after the fact to cover their tracks. Let's consider another example, the case of Shantae Mallard, who hit a pedestrian while driving under the influence of alcohol and drugs. Toxicological analysis of her and the victim revealed she was highly impaired, which directly led to her conviction for murder. The toxicology results established a timeline that showed her state of mind and physical condition during the crime. Toxicological analysis employs multiple scientific methods to accurately detect and measure substances. For drugs or alcohol, blood analysis is the gold standard. Alcohol concentrations in the blood, known as BAC, help determine whether someone was legally intoxicated. For longer detection windows, urine or hair samples are used, especially in cases involving drugs that stay in the system for weeks, like cannabis. Gas chromatography and mass spectrometry are two common techniques used to break down and measure these substances, allowing forensic toxicologists to provide exact concentrations. This level of precision is essential for linking a suspect's level of intoxication to specific actions or behaviors. The outcomes of these examinations are invaluable in criminal proceedings. Toxicological results can confirm whether a victim's death was accidental or deliberate. For example, in cases of poisoning, the detection of substances like cyanide or arsenic can prove malicious intent. In the Jonestown massacre, where over 900 people died from cyanide poisoning, toxicology reports confirmed the substance used in the mass suicide, helping to reconstruct the tragic event. In addition, these findings can influence sentencing and guilt determination. In cases of impaired driving, for example, BAC levels directly affect whether a crime is charged as manslaughter or a lesser offense, like DUI. Toxicological analysis is more than just a tool for identifying substances, it's a critical method for piecing together what happened in the lead-up to a crime. The scientific precision offered by toxicology allows investigators to establish timelines, understand motives, and ultimately, bring about justice in many cases. For graduate students and criminal justice professionals, developing a solid understanding of forensic toxicology is key to navigating modern investigations, as it often provides the most objective data in otherwise unclear situations.